Algebraically, the distributive property works with division the same way as it does with multiplication. Conceptually, it's all about rearranging the boxes in the picture. Before we get to the picture, we will do a purely algebraic manipulation. Example, compute the quantity 60 plus 12 divided by 6 using the distributive property. Mechanically, this is exactly the same as the distributive property of multiplication, except we will write division symbols instead of multiplication symbols. 60 plus 12 divided by 6 is 60 divided by 6 plus 12 divided by 6. 60 divided by 6 is 10, and 12 divided by 6 is 2. 10 plus 2 is 12, and that's the final answer. Most students learn how to do long division, but have very little sense of what it is or why it works. It's all about following the mantra, divide, subtract, multiply, bring down, and then you repeat that over and over and over again. In this class, we will not be working with long division, at least not in the form that you're used to seeing it. What we will do instead is show how simple reasoning can be used to work through a complicated division problem. Example, use a grid to compute 96 divided by 4. If we were to try to do this by just making groups of 4, the calculation will take a very long time to get up to 96. We need to think of a better way to count. Our past experiences should lead us to think about making clusters of 10. This means that instead of counting by 4s, we'll be counting by 40s. We will line up our boxes vertically like this to represent groups of 10, and then we'll have 4 of those. So that's 40, and then 4 more of those makes 80. And if we tried to go one more, then we'd get up to 120, and we don't have that many objects. How many more boxes do we need in order to get up to 96? From 80 going up to 96 is 16 more, and so we can draw those now individually. How many total groups do we have? The bottom 2 large groups each represent 10, so 10 and 20, and then 4 more makes 24. So there are a total of 24 groups. This tells us that 96 divided by 4 is equal to 24. We can see that this picture takes a lot of time and space to draw. The picture is intended to guide our intuitions, but in the end we want to be able to compute this symbolically. So we will look at it again, starting from the original problem. 96 divided by 4. What was the process? We started to try to count to 96 by 4s, 4, 8, 12, 16, 20, and so on, and decided that that would take too long. So instead of trying to count up to 96 by 4s, we will count by 40s. 40, 80, and then one more is 120, and that's too many. So we took our 96 objects and pulled out 80 of them as a useful grouping. If we pull 80 from 96, we are left with 16. So we have 80 plus 16 divided by 4. And now we can use the distributive property. 80 divided by 4 plus 16 divided by 4 is equal to 20 plus 4, which is 24. There are many students who struggle with this section. But after working with them, most of the time I find that it's because they stop trying to use logic and reason and are just looking for someone to give them a purely mechanical process to perform so they don't have to think. Unfortunately, that's just not good enough for us. We want students to learn to think for themselves and to use this ability to solve problems. So we will challenge you to apply your knowledge and experience to learn how to approach these problems in a new way. Example, compute 282 divided by 6. In order for us to do 282 divided by 6, we're trying to take 282 objects and make groups of 6 and count the number of groups that we have. If we try to do just groups of 6, 6, 12, 18, 24, 30, 36, 42, and so on, it will take us a long time to get up to 282. So instead of 6s, we will first start by thinking about 60s. 60, 120, 180, 240. If we go one more to 300, that's too many. So 282 is 240 plus however many is left over. In this case, we need 42 more to get up to 282. So 282 divided by 6 is the same as 240 plus 42 divided by 6. And now we will apply the distributive property. 240 divided by 6 plus 42 divided by 6. That gives us 40 plus 7, which is 47. The whole trick to this is that we are rearranging the information, the 282 boxes, into groups that are useful to us, 240 and 42. These numbers are useful because 6 goes into them very easily. We will do one more example. Example, compute 1044 divided by 3. The process here is exactly the same. 1044 divided by 3. If we start counting by threes, 3, 6, 9, 12, 15, and so on, it will take us a long time to get to 1044. If we do 30s, 30, 60, 90, 120, 150, it will still take us a long time to get to 1044. So instead of 30s, we will go up one more step and go to 300s. 300, 600, 900. If we go one more to 1,200, that's too many. So we break this up into 900 plus however much is left over. In this case, that's 144. And now we will apply our logic to the number 144. If we try to count by threes, 3, 6, 9, 12, 15, it takes a long time to get there. So we will count by 30s. 30, 60, 90, 120, and we're there. So this is 900 plus 120. Well, let's see, 144, and we pull out 120. How many's left? Just 24. And now we use the distributive property. 900 divided by 3 plus 120 divided by 3 plus 24 divided by 3. That's 300 plus 40 plus 8, which is 348. It turns out that this is exactly what happens during long division. It's just that by doing this as long division, you don't get access to the concept that's underneath the problem.